Okay, today we are working on circle segment theorems. So to start off, we have tangent tangent. So this is where, so all of today is going to be about segments intersecting or passing through our circles. Tangent tangent is where I have two tangent segments. So those are ones that only touch the circle at one point. What is interesting about these tangents is that they will be congruent. Okay, two tangent segments are congruent when they share that vertex. So my formula is tangent equals tangent. So what does that mean? That means that the length of AB is the same length as CB. Secant tangent. So these are segments that intersect and go through the circle. So to find the whole length, be sure to add both parts. The formula is outside times whole equals outside times whole. So for our top segment, outside is the A part. The whole thing, I'm adding these pieces. The whole is A plus B. For the bottom segment, the outside is the C part. The whole is C plus D. Chord. So these are segments that are inside the circle. So finding lengths of two segments inside the circle. Our formula is part times part equals part times part. So for our first segment, AB, so it'd be like A times B equals C times D. Secant tangent is very closely related to secant. So this is where we usually do the secant one on the left, so the one that's passing into the circle. So that would be B times, so outside times whole, so B plus C. For the tangent, it's outside squared, so A squared. Really, that's kind of like outside times whole, where the outside and the whole are the same thing. So it would be A times A, which is A squared. So let's jump into our first example. We need to state the theorem used. So this first one is chord. And these are all formulas you need to memorize. So each one of these. Tangent, outside whole, part times part equals part times part, outside times whole equals outside squared. That's how you'll be asked to write them on your equations test. So for this one, it's part times part equals part times part. So 10 times x, 10x equals 14 times 15. So 10x equals 210. Divided by 10, so x is 21. So if this is 21, I could go back and ask you to find the entire length of whatever segment. The next one, both of these segments start outside the circle and pass into the circle. So this is secant. So it's outside times whole. So outside is 10 times the whole is 10 plus 42 equals outside is 13 times the whole is 13 plus x. On the left, it is 10 times 52. So that would be 520 equals. On the right, we distribute. 13 times 13 is 169. 13 times x is 13x. Subtract 169, and we get 351 equals 13x. Divide by 13, so x is 27. Then I asked you to find n all the way to L. So if x is 27, this section is 27, then we add 27 plus 13, and we get 40. page. Both of these segments do not pass into the circle, so those create tangent segments. So this is tangent, tangent. What do I know about these? I know that tangent equals tangent, so I'm going to set these equal. 8x minus 19 equals 5x plus 23. Subtract 5x, so 3x. Add 19, so 42. Divide by 3, so x equals 14. Then I was asked to find CB. Realistically, I should be able to plug it into either. So 8 times 14 minus 19 is 93. Number 4. Okay, one of these is a tangent segment and one is a secant. So this is, you can either say tangent secant or secant tangent. It does not matter. When we set up our formula, we do outside times whole. So 9 times 9 plus 16 equals, really it's outside times whole again, so outside is 3x times the whole, which is 3x again, so I'll write this whole thing squared. Don't forget to put it in parentheses. So this is 9 times 9 plus 16, which is 25. So 9 times 25, I guess I'll write that. 9 times 25 is 225. On the right, I need to distribute this to each of these parts. So 3 squared is 9. X squared stays x squared. We'll drop that down. Trying to get x alone, so I'm going to divide by 9. So x squared equals 25. Square root both sides, so x equals 5. If I wanted to find this tangent segment, I'd do 3 times 5. All right, both of these segments pass into the circle, so secant, secant. Outside times whole equals outside times whole. So 9 times 9 plus x equals 8 times 8 plus 19. So 9 times 9 is 81, plus 9 times x is 9x. And we have 8 plus 19 is 27, so 8 times 27 is 216. Subtract 81, 135. Divide by 9, x is 15. Number 6. Both of these segments are inside the circle, not leaving, so this is chord, chord. Part times part equals part times part. So I like to have my variables on the left just for consistency's sake. So I'll do 4 times 5x minus 1 on the left, 6 times 6 on the other. So 4 times 5x is 20x. 4 times negative 1 is negative 4, equals 36. Add 4, so 20x equals 40. X equals 2. I wanted to find DB, so first I have to find this bottom segment. So 5 times 2 is 10, minus 1 is 9. 4 plus 9 is 13. Number 7. These are tangent, tangent. those segments are congruent, so I'm going to set these equal to each other. 43 minus 2x equals 12x plus 1. Add 2x to both sides. 12 plus 2 is 14x. Subtract 1, so 42. 42 divided by 14 is 3. I want to find wy, so 43 minus 2 times 3. So 43 minus 6, 37. The next one, see if you can try it on your own. Okay, so we have a tangent line and a secant line. So secant tangent. Outside is 8 times whole, 8 plus 5x minus 1 equals outside squared, so 16 squared. So I have 8, I'm going to combine my like terms. 5x, 8 minus 1 is 7, equals 256. Distribute on the left, so 40x plus 56 equals 256. This is working out well. Subtract 56, so 40x equals 200. Divide by 40, so x is 5. I was asked to find NP, so I'm going to plug in for 5 times x, which is 5 minus 1, so 24. Okay, the last ones. These ones are finding perimeter of a triangle. So we have DEF is a triangle that is all the way around a circle. This triangle is made up of, if I kind of ignore all of that, it's made up of multiple tangents. So we'll be using the tangent theorem. Okay, what's important here is that we can match these up. So if this one's 11, then this one has to be 11. If this is HE is 16, IE is 16. They have the same vertex here. And GF should be 9.5. To find perimeter, we will add all segments. So if I add these up, 11 plus 11 plus 16 plus 16 plus 9.5 plus 9.5. Just throw it all in my calculator. 73 is our perimeter. Number 10, last one. So this one, we're adding some challenge to it, of course. So we have segment theorem. So first, this is tangent. Okay, and we are making work for it a little bit. So right here, I know that this one ought to be 9. Okay, that's as far as I can really go without doing any computations. So first thing I'm going to do is look at R's vertex here. I have these two segments. They should be equal. They have x's, so I'm going to set those equal. So 5x minus 8 equals x plus 4. Subtract x, so 4x equals, add 8, so 12, x equals 3. So I want to plug that in now. Oh, and I did ask for x up here, so 3. So this is 3 plus 4, so 7, which means this is 7. And we could always double check. 5 times 3 is 15, minus 8 is 7. All right, now we can tackle our y's. Again, we have two congruent segments, so we'll set them equal. 3y minus 10 equals y plus 2. Subtract y, add 10, y equals 6. So I'll add that to my line. So here, 6 plus 2, that means this section is 8, so is this. If from P to Q is 13, and this is 8, to find this segment, I'll do 13 minus 8. 5. Okay, I now have all of them added, or labeled, so I will go ahead and add them up. So 9 plus 9 plus 8 plus 8 plus 5 plus 5 plus 7 plus 7. And I'm getting 58. Don't forget we have a quiz next class.